Hi, I'm Thomas, and I want to give you a quick overview of a software project me and my colleagues at Framefield have been working on for the last couple of years. This project is open source, completely free to use for commercial, non-commercial projects. It's called Tool3, and yes, it's of 2L. And yes, it's a third version of this project, and it's a real-time procedural content animation tool. So it's running right now. So in fact, this is real-time. So you see, that you can change title, change the string on the fly, or adjust the headline, things like that. And so you can obviously things like this fluid simulation in the background. You can do things like color correction. So if I turn this off, see less color correction. You can do really advanced stuff like having things like vectorscope and waveform, things like that. And so in the next couple of minutes, I want to give you a quick overview of why we do this, what this is about, and why this might be interesting for you. So let's get started. So if you think about like a Venn diagram, and let's say you have like real-time animation, like things you would expect from gaming softwares like Unity or Unreal Engine, things like that. So you have all the advantages of like real-time stuff. So there's no rendering time. If you press preview, then you see the content with 60 frames per second. You have can do things like VJing on the fly, sync to music, all these kinds of things. So then you have things like keyframes, so stuff you would expect from tools like After Effects or Blender or so. So you have like linear animations, you can have time clips, you can sync to audio, like not live audio, but actually really cater for like animations and transitions for things like music videos or demo scene productions. And then you have like procedural content, like you would expect from tools like Houdini or Grasshopper. So you have graph-based, really complex stuff. You have like caching, you have invalidation. You obviously can write not only combine logic or build logic by connecting boxes, but you can also, of course, write stuff like shaders or like program your own nodes in C#. So if you have like real-time keyframes and procedural content generation, so we want to have the small little corner there in the center in the overlap. So yes, each of like these industry leading or even open source tool expanders are like really good at doing their stuff, but we want to do everything with real time and so being fast and painless and focus on like nice little content creation tools. So to give you some examples of what you can do with this, I have some examples here. So if you you can imagine things like things that are animated to soundtrack. If you load a soundtrack, so you could do this here, and you adjust like the BPM rate or things like that. So you can build animations that are very carefully synced to audio soundtrack. And then of course you can use FFT and all kinds of other fancy things, beat detection and so on. But you can combine real-time animations and driving keyframes and do parameter sweeps to find the best parameter settings for your simulations or these kinds of things. Then we have things like this example. So you have, maybe if we dive in here, so we can quickly see what's going on here. So we have files in the folder, so you can just say folder, then you this gives you the file names, and then you get a list of files, and you pick one of these. So you load this on the fly, you project this or render this, or maybe rotate it, for instance, render this into texture, and then you can do things like, for instance, mirror repeat, the thing we have going on right now, or you can, let's say, do like Koch-Kaleidoskop things, or maybe like small little effects like this. And everything, like all of these parameters, can be driven by MIDI controllers. So it's really straightforward to adjust these settings. And you can have them running in the background, or you can stop this animation and then really go in here and tweak like how certain transitions look like. You can also do things like this one here, which is a small little animation video. So we go back here. So this one is like super simple. It's only like these notes. This is everything there is for like this whole animation. And since it's a procedural animation, it's like perfectly linked to this specific tag for which it has been built for. Maybe like here's another example of some procedural content. So you can create point lists and instantiate geometry at these points and do mesh deformations, things like that. We have this little example here, which is an interactive installation we built. So maybe if we turn off the timeline here. So this one was connected to an external console where you could drive this interaction, and you could start the simulation here. And in this case, the people I built this with had a very clear vision of what they wanted to show. So right now, so we don't have the correct fonts installed right now, but so you can imagine this being running on a large screen, and people could explore like the different simulation steps here. And yeah, so like I think you get the idea. So it's graph based. It tries to be as simple and reduced to certain effects. And I think the best thing is probably if I quickly build something from scratch, so you can get an impression of what you can do right now. So maybe clear this here. So you can switch between like different layouts, and you can of course have several output windows, and normally you would also run this on multiple screens. So you have like one secondary screen with the full screen output. That's also useful for VGA things and so on. Right now, for this recording, I only have this one, so it should be sufficient. And then you could either use this resolution of the current output window, which we see here. So if we reduce this, we see like the resolution being changed there. But you could also set this to high screen, like higher resolutions, and then zoom in here and see like how this would look at up close, such like that. So let's try to build something from scratch. So let's start simple, and we create an operator by pressing tab. And then right now we have this grid points here, which doesn't really do much. So let's draw these points. So this generates a list of points. We can rotate this here like you would expect of this. So let's pin this to the output, and maybe we reduce the depth here and press F to go back to the front view. So we have different boxes here. These boxes indicate what kind of primary output this operator creates. Brownish means that this is a buffer on the GPU. So this can be tons of points, and it will still run fast. It can be a lot of points. and it shouldn't matter because it's running on a GPU. This one is cyan because it's drawing stuff, it's a draw call. And then we could, again, render this into a texture. So we use this, we have a texture here, and then we can start to insert other things. For instance, like modify a camera to have like a fixed control. So maybe we don't need this in 4K. So let's do this in full HD, should be good enough. And then let's build something more interesting. So let's first maybe reduce the size of the points here and increase the size of this grid. Maybe we have more grid width and we change the size here. And so we could do things like randomizing these points to have more variation in here. And then of course we could animate any of these. So if we have like this random thing here, we could set a keyframe. Maybe so let's do this. Go to the beginning of our animation. So the keyframe here, and set another keyframe here, maybe to reduce it. And then we already see that this is very similar to an editing software you would expect. So maybe we put this in the background to see the better resolution here. So let's drop this to the background, zip, and change back to this full screen modus, which is a bit prettier. So so we have like this random thing here going on, which is not really exciting. So maybe we also add some noise to it. We see that okay, looks interesting. So of course we can animate this noise. So let's drive this by the time. Oh, okay, looks kind of interesting. Maybe increase like the depth here. So maybe it's a little bit too fast. We see here this is running, although I'm not playing the time, it's still running. So I get a preview of how fast the animation is. If I scrub the time, I still get the perfect time slot. So I have a nice combination between doing precise keyframe-driven animations, but you can also sometimes have the animation just running in the background. I can of course pause this here. And then maybe you can go on and build something more interesting here. So let's say we want to drive the size of these points by a texture. So then we could use text, and we could render this text into a texture, and then maybe we decide not to have like a random resolution, like this current screen resolution, or like this. Right now it's like full HD. Maybe we say, okay, we have a square resolution here. We can override this, and we can use this to drive some aspect. Let's say we want to have use the brightness of this buffer to drive this W parameter. Okay, we move this away a little bit. So we see, something is going on there. Maybe we also adjust the size of this. So let's make this a little bit bigger. And okay, something is going on there, which is already interesting. So let's use this buffer here, and let's maybe first let's increase the size of this. Maybe let's say we call this tool. And maybe we can later, of course, we can animate this. Let's go in here and maybe increase the size of this a little bit further. So maybe let's blur this. Maybe let's increase this further. Okay, looks kind of interesting. So maybe you can also drive this animation here and say, okay, like this should also drive the how far it is coming out. Okay, this also looks kind of interesting. Maybe we also set a little bit of fog in the background so to get it, give it more depth. And maybe we can build a small little transition here to let this fade in. So let's see again how fast this is. So maybe in the beginning we make it very blurry. So let's increase the sample count here, make it very big. So let's create a keyframe here. Say, okay, in the beginning is big, and then it's slowing down to be readable. Maybe keep this keyframe there, so it's easier to see. Then maybe we also animate the font size. So let's make it big in the beginning and a little bit smaller in the end. So, and then of course we should also animate how far we are driving this thing here. So let's make it also drive this down a little bit. And well, maybe we also reduce the noise amount here. So actually, it's really looked actually nice, but there's also like this this amount parameter. So maybe we quickly change this to the face again, and then we say, okay, we animate this thing here, and we let's move this in here. Let's add a new keyframe, and you might notice that like things are snapping nicely. So if you move things around to the snap, you can do things like scale your keyframes. Of course, you can also decide to use a curve editor, and of course you can also have things like smooth animation curves. And then if you go back to the screen, you of course can see better the curve editor there. So let's go back to the full screen view. Okay, so we have a small animation, and we wanted to go back here and maybe some key like these. All these we have them in view. We wanted to reduce the noise curve. Yeah, this is what we wanted to do. So let's go in here. So the noise curve is 10 in the beginning, and it should be 0 at the end. So, okay. Okay, so it's getting there. Maybe like the final keyframe here is a little bit too low, so we can go here, and then of course we can edit the keyframes directly. And yeah, so it's getting there, but it's still like kind of okay by points. So obviously we can also do 3D stuff. So let's take a cube mesh here and draw mesh points, and we use these points to draw also cubes. Maybe keep the fog setting there. We have an operator called execute, which has an unlimited amount of inputs. So this looks quite chaotic because these cubes are way too big. But if you scale them down, we see, okay, there's something going on here. So maybe we also want to set the material of these, and maybe less metallic, and shinier. Maybe you also want to add some post-processing like glow or so. And maybe we just maybe do like a tone mapping. And maybe we also do like a color grading, so to give it a little bit of tint and increase the contrast a little bit. Maybe increase the shadow amount there. So okay, this looks kind of interesting. If you see here the procedure animation, I think it's still too fast. So let's break this down a little bit. So maybe we can also add a point light there. Let's move this around a little bit. So move this up, move this a little bit towards the camera. We can increase the brightness there and maybe adjust the color slightly. And okay, this looks kind of interesting. So of course this is procedural, so we could do things like, okay, like how would it look like if this would be not be cubes, but more like rectangular boxes? Okay, well, so maybe with adding some SSRO it might be more interesting. And then we had this randomized points here, which we are not really using right now, but I think we should also like rotate these cubes here, so it looks more interesting, more glittery. Okay, getting there. So let's see this again, how this looks in animation. Okay, that's actually, well, you get the idea. So it can be quite elaborate. And then of course, at any time you could add any property and for instance control it with a MIDI controller. So in fact, I have a MIDI controller right here. So if you increase this one here and say we have this noise thing, and let's say we want to like check the different frequency styles. So we could say MIDI input, and then now I'm controlling this with my MIDI controller here. So it's automatically teaching and learned that I'm controlling this with my APC Mini. And of course, I could change the damping or increase the value range or things like that. So I don't know why this would be a good idea, but you could. Since these computators here can be combined in very flexible ways, so for instance, you could do things like, let's say, smooth transform, soft transform points might be a good example. So if you turn on the gizmo here, so you could do things like move these points around. Okay, this looks interesting. So maybe we change the size of this volume here, increase the fall off, and so we can actually see, okay, that so okay, this looks kind of wanky, but I think with you get the idea. So you can do interesting stuff and play around with them. And but I personally, that's the reason I'm doing this. I have a lot of fun playing with these and doing all kinds of different designs and just playing with procedural content. So so a little bit, so why we are doing this. So, and yeah, as I said, the name of this tool, so let me get back to my slide. Where was my slide content? The slide content was here. Yeah. So back to my slides. We don't need the timeline anymore. Hide the timeline. So this is the third version. So right now it's written with a library called Imgui. It's all open source. It's a super awesome library, which makes it really easy to build user interfaces that run smoothly. And are nice to extend. And it's running on DirectX. So right now it's Windows only, but I will later say a little bit about like how we might change that. And it's a third version. The first one was Qt with OpenGL. The second one was WPF, which is a Windows library, Windows Presentation Foundation, I think it's called, which was a horrible UI library and was very slow. And that's the reason why we couldn't really use it for VJ content. And this one we wrote from scratch, and we tried to optimize everything from the UI. So user interaction design, we did tons of usability tests and mocks and click dummies and so on. But also like software architecture wise. So if you see, let's make a simple example here. So very simple would be shader development. Let's say you want to have a simple thing like that, apply and detect edges here. So as an artist, you don't have to do this, but as a technical artist, you might want to do this. So you could actually jump in here and you see, okay, this is like a nested operator. So maybe we clear the background here and turn this into the side output here. So this is a nested operator. And so we are in my dashboard and in the operator with the pitch. And right now we are under detect edges. And this one, again, uses another operator. And this one goes really down there into DirectX land. So these are DirectX API calls, you could say. So we have like the input assembler stage, vertex shader stage, rasterizer, and so on. And all these are this is basically mapping the complete DirectX 11 API. So everything you can do with DirectX 11, you can actually do with Tool without needing to writing any code. But you could. So this is a reused operator. And it exposes a bunch of parameters. And one of the parameters it's exposing is the shader source code. And if I click here on edit, then I think OBS is not capturing the overlay, but I right now Visual Studio Code opened. And let's say if I'm editing this here, so you have to trust me, right now I'm writing GSL and I'm writing a line that adds like a little bit of red to the output. And if I press save, we have a file watcher that automatically compiles the code and tells me, like, executes it on the fly. And if I write something stupid, like a spelling mistake, it will tell me so and give me like a proper warning there. So this is a warning is incorrect. So this is a warning there. So we also do things like adding nice little debug parameters to make debugging easier with external tools like RenderDoc. So this might be a very simple fragment shader, but you can do things like a spatial hash map. I think there's like one here. So you can do very complicated things. So this one nests like a bunch of compute shader stages, compute shader passes. And in between these compute shader passes, it does a prefix sum, which is another algorithm that is useful for a lot of graphics card algorithm. And you can go in there and see like, okay, this one again nests a bunch of compute shader passes. So you can actually do these kind of graphs without like getting totally insane. And sometimes it's also fun to experiment with these things. So the use cases. So what are, like, for whom is this? So why would you care? So obviously if you are a technical artist, this might be super interesting for prototyping things. And so I have a strong background in tools like Unity and Touch Designer, and I would say this is much easier to do compute shader development and prototyping with this thing here in a graphical layout and seeing what the API is doing. Obviously, if you are a VJ, you can build super elaborate VJ sets with MIDI controller setups, sensor inputs, stuff like that. And if you are coming from tools like VVVV or Touch Designer, this is probably super easy to get into. Then obviously you could do 3D animations, like demo scene animations, and export these demo scene animations as executables. So this means that we strip all the ImGui stuff and all like the external libraries and dependencies, and you have an executable. I think let's say the complete executable is like 2 megabytes, and then you have like your resources like an MP3 or so. So you can have like pretty small, it's not 64K, but it's small. And then of course you can do interactive things and prototyping. So let me scroll through my list of things I wanted to say. Yeah. So what's the current state? The current state is we are working on this. So it's open source. So if you go to github.com/scene/t3, so I will post this URL in the description of this. You can currently install it and run it. There is also a selection of YouTube tutorials that give you a quick introduction on how to work with these procedural content things, how to work with the UI, how to do animations. So you have some start. Installation right now is kind of tricky. So we are working on this. It's pretty clear what needs to be done, but right now you need a technical setup that it's possible, but it's in the development phase. And yeah, what we are looking for now is testers, people that are using this thing, trying to figure out what's working great, what needs improvement, what's missing, suggestion, how like things should be named or restyled and so on. We are also, it would be super nice to have people that build examples or help us with examples and documentation. So there is some documentation there, but it's could be much better. So I'm definitely not a strongest documentation person with my strong German accent. And also, if you are having a C# background, this might be super useful and a very fun project to work with. And so in the long term, so it needs to be stabilized. There is a very long list of features and improvements that we want to implement, like having the ImGui docking branch working, adding more sensors, adding camera input and hub video playback and so on. So there's a long list of things we have on the agenda, and it's all possible, but we are working on it. And if you extend this and think like a little bit into the long-term future, then for us, our vision is, so, okay, you have GIMP, which is an open source software that at least tries to replace Photoshop, and some people say it's successful with that. So you have Blender, which does an excellent job at replacing or being a substitute for 3D Studio Max and Maya. And obviously the Blender team is super successful and they're doing this for a very long time. But I think there's like right now no open source replacement for tools like After Effects and Houdini. And yeah, wouldn't it be awesome to work on a project that does that? So yeah. So if you are curious and want to know more, we have a Discord channel. We have a YouTube channel. And we have GitHub. So if you have any questions, you can reach out in any of these three. We are a nice bunch of people, so we are listening, we are super curious, and we want to build a community to work on this thing. So yeah, this was all I have for now. Thanks for watching. Bye.